Bianca Cavazzin.
Hello everybody, thank you for coming. It's actually pretty great to see so many people here. I'm Bianca and I'm part of the School of Geographical and Earth Sciences, and I have changed the title from the original abstract, but it doesn't really matter. All you need to know is that today I'm going to talk about planet Earth, and in particular I'm going to talk about climate change. So I'm sure that many of you know about climate change, or at least global warming. But what I'm actually interested in is the climate change that happened a couple of thousand of years ago, before human had any kind of significant impact on the climate and the environment. So my study area is the Canadian prairies, which is highlighted on the map in red. And the Canadian prairies are very important for Canada and for Canadian economy, and that's because they actually include the vast majority of agricultural land, so they're very valuable for Canada. One of the problems is that the Canadian prairies are affected by extreme climate, and one of them, and probably the most costly hazard, is droughts. So drought is basically just shortage of water, and is obviously bad for agriculture, because without water the crop cannot grow, but it's also bad because one of the implications of droughts is actually wildfire. And these are articles that came out a couple of months ago in the news from The Guardian and the BBC. And this is a wildfire that was caused by 4 months of droughts in the Canadian province of Alberta. And as you can see, the wildfire caused a huge amount of destruction, and the economical loss was immense. So now, the thing to remember is that the climate outside has not always been the same, and things actually change quite quickly. And the climate that happened a few thousand years ago is actually very different from what happened now. And we have a succession of extreme climates in the kind of planet's history. And one of them is glaciation time. Very cold, polar ice cap expand, and the entire basically planet is covered in ice, so it's very cold. And the other one is when glacier melts, and we have warmer climate. We are in interglacial period right now. But the curious thing is actually those kind of interglacial time can get much warmer than now. So this is a period called Eocene that happened millions of years ago. And the thing that is very interesting is that the polar ice cap, that didn't exist, and actually we have a tropical climate at the poles. And we have found remains of crocodile to testify what happened. So the thing that I really wanted to take from this talk is that the past is the key to the future. So if we know what happened in the past, then we might have a better understanding of what's going to happen in the future. So that's where I come in. That's when my research come in, is basically just reconstruct what happened a couple of thousand years ago. And the planet is actually pretty good at leaving clues behind, and those clues we call Proxy. And basically they represent what happened in a specific period of time. This is one of the clues of Proxy, they're fossils. This is probably what everybody thinks when I talk about fossils, but actually this big guy and dinosaurs in general that don't tell much about, well, to someone like me at least, what happened when they lived. So we need to go to a much smaller scale, and we need to have a look at bacteria. Bacteria cell membrane in particular respond to climate, so they adapt to the climate that they live in. So for example, the bacteria that will live during an interglacial time, that would be very different from the bacteria that live during glaciation. So these kind of bacteria, they're good, they're great actually, because we found bacteria everywhere on the planet. And when they died with rainfall, they accumulate in lake sediment. And over thousands of years, we have an amazing record of what happened when those bacteria used to live. So all you need to do is actually get those cores, those sediments, and you need all you need to do is core sediment lake, which is basically just drilling down meter by meter to get something like this. This is actually quite beautiful, and it comes from Eastwick Water in the Lake District. And we can see at the bottom part lots of lamination, which is representative of a glaciation period, and then kind of the mud part at the bottom, at the top, sorry, is kind of the period that we're in now, so kind of interglacial time. So once we have the core, we need to go back to the lab, and we need to sample the core and take some sediments, and we need to extract the organic matter, which is simply just the bacteria. And for me, the easy way to explain it is thinking about food. I'm Italian, always thinking about food. So we start with breakfast Cocoa Pops, and so if we add Cocoa Pops to milk, the milk dissolves the chocolate coating around the Cocoa Pop. So if we sieve out the Cocoa Pops, what we're left with is chocolate milk, delicious chocolate milk. So we do the same with our sediment. So if we put the sediment in a solvent, which is our milk, and then we pass the solution of sediment and solvent through a column, which is filled with powder, usually silica, then the stuff that we're not really interested in stays in the column, but the organic matter, therefore the bacteria, just percolates down through the column, and we can collect that bacteria into small containers. So the next step is to analyze the organic matter, and we do that using the same principle as a coin machine. So we start with the coin, and we put the coin in a coin machine, and basically the coin machine works just weights each coins. So each individual coin has a different weight, so 20p would have a different weight than a 50p. And basically the machine just tells you at the once it calculates everything, it just tells you how much money you've put in. And our machine does exactly the same. Unfortunately, it doesn't give you cash at the end, but so we put our sample in the machine, which has a very fancy name, high performance filtering chromatogram. But basically all it does is just weight the different bacteria cell membrane, and each cell membrane has a different weight. So at the end, the machine just kind of spits out the graph over there, and each individual peak is representative of a different bacteria. So basically, we just need to count those peaks, and knowing as I said before, knowing the different bacteria cell membrane thrive in different environments, we can understand and reconstruct what happened in the past. And we end up with something like this. This is an average temperature for the last 1,000 years in the northern hemisphere. Some of you might be very familiar with this image. And we have a couple of, I just picked like 2 examples of some really interesting events that happened in the last 1,000 years. One is the medieval warm period that happened in the Middle Ages, as the name suggests. And actually, during this time, the Canadian prairies were hit by multi-decade droughts, at least 4 of them, causing kind of massive destruction of the environment. But then a little bit later on, we have what's called the Little Ice Age, and this is a global event that obviously hit the prairies, but you might be familiar with some of this painting in the National Gallery. This showed the Thames, the River Thames in London froze over. So some of these events are local, some of the other events are extra local, but basically this is what my research does. It's just reconstructing what happened. And as I said before, the data that we get is extremely important to understand what's going to happen in the future. So if we have a better understanding what happened in the past, then we might be able to predict how plants and animals are going to behave in the future. So thank you very much for listening.